Hey everyone, and welcome back to the channel. Today we're diving deep into one of Earth's most spectacular and powerful events, volcanic eruptions. Have you ever wondered how scientists know when a volcano might be about to blow its top? It's not about crystal balls or guesswork. It's about science, observation, and understanding the subtle language of our planet. So what happens when a volcano starts to wake up? What are the warning signs and what comes next? Let's break it down. Imagine a volcano as a giant underground pressure cooker. Deep beneath the surface, there's a chamber filled with magma, which is just a fancy word for molten rock. This magma is packed with dissolved gases, kind of like the bubbles in a can of soda. As long as the pressure from the overlying rock is strong enough, everything stays contained. But when new magma rises from deeper within the earth and pushes into this chamber, or when the rock above it weakens, that's when things start to get interesting. The pressure begins to change, and the volcano starts sending us signals that it's getting ready for a show. One of the first and most important signs is ground deformation. Think about it. If you're pumping more liquid into an underground container, the ground above it is going to swell and bulge, right? It's like inflating a balloon under a carpet. You might not see the balloon, but you'll definitely see the carpet rise. Scientists use incredibly sensitive instruments like GPS, tilt meters, and satellite radar to measure these changes. We're talking about movements that can be as small as a few millimeters, but they tell a huge story. When the ground around a volcano starts to swell or tilt, it's a clear indication that magma is on the move, pushing its way up from below. This is a primary red flag for volcanologists. Next up, let's talk about earthquakes, but not the kind you might be used to. These are special types of tremors called volcanic earthquakes. As magma forces its way through solid rock, it cracks and breaks the rock, creating a series of small, frequent earthquakes. It's like the sound of ice cracking as it expands. Scientists deploy networks of seismometers around volcanoes to listen for this underground chatter. They don't just count the number of earthquakes, they analyze their depth and type. Are they deep, indicating magma is still far down, or are they getting shallower and more frequent? A swarm of shallow earthquakes is a classic sign that magma is getting dangerously close to the surface. It's the volcano clearing its throat before it shouts. Another crucial clue comes from the gases the volcano is releasing. Remember those dissolved gases in the magma, like in a soda can? As magma gets closer to the surface, the pressure drops, and these gases start to bubble out and escape. It's the same reason a soda fizzes when you open it. The main gases scientists look for are sulfur dioxide, SO2, carbon dioxide, CO2, and hydrogen sulfide. You might recognize the rotten egg smell of sulfur. That's a telltale sign. Scientists use spectrometers, which are special tools that can analyze the composition of the gas plume from a safe distance, either on the ground or mounted on aircraft and satellites. A sudden increase in the amount of sulfur dioxide is a major warning, as it often signals that a fresh batch of gas-rich magma is nearing the surface, priming the volcano for an eruption. So, scientists are seeing the ground swell, hearing the earth tremble, and smelling those volcanic gases. What happens next? This is where the warning system kicks in. Volcanologists don't just rely on one piece of evidence. They put all the data together: ground deformation, seismic activity, gas emissions, and even changes in temperature detected by thermal cameras. They're looking for a pattern, an escalation. Are all the signs increasing at the same time? Is the rate of change speeding up? This synergy of data helps them build a forecast. Based on this combined evidence, volcano observatories issue alert levels. These are often color-coded like a traffic light system, to make them easy for the public and authorities to understand. For example, in the United States, the system goes from green, meaning a volcano is in its normal quiet state, to yellow, which means it's showing signs of unrest. Then it goes to orange, indicating heightened unrest with an increased potential for eruption. And finally to red, which means an eruption is imminent or already underway. These alerts are not just for show, they trigger real-world actions. When an alert level is raised to orange or red, emergency management officials kick into high gear. They use this information to make critical decisions like closing off certain areas, redirecting air traffic to avoid hazardous ash clouds, and, if necessary, ordering evacuations to get people out of harm's way. The goal is to move people to safety before the eruption happens. The communication between scientists and public officials is absolutely vital. The scientists provide the data and the forecast, and the officials use that to implement safety plans. It's important to remember that every volcano is unique. Some, like Kilauea in Hawaii, tend to have less explosive eruptions with slow-moving lava flows. Others, like Mount St. Helens, can be incredibly explosive, sending massive ash clouds miles into the sky. Scientists have to study the history and personality of each specific volcano to understand what kind of eruption it might produce. They look at past lava flows and ash deposits to piece together its eruptive history, which helps them predict future behavior. Forecasting a volcanic eruption is a complex and evolving science. It's not about predicting the exact minute it will happen, but about identifying a period of increased probability and taking smart, protective measures. Thanks to these dedicated scientists and the technology they use, we can now listen to volcanoes better than ever before. Their work provides the crucial lead time that allows communities to prepare and respond, turning a potential catastrophe into a manageable natural event. It is a powerful example of how science helps us live more safely on our dynamic and ever-changing planet. Thank you so much for joining me today to explore the fascinating world of volcano warnings. I hope this helps you understand the incredible science that goes into keeping people safe. If you found this interesting, don't forget to hit that like button, subscribe for more deep dives into our amazing world, and ring that notification bell so you never miss an update. Stay curious, and I'll see you in the next video.